Okay, well, it's the last exercise on areas between curves, and they are bringing the heat. Look at these things. Two, two polynomials, and they aren't simple ones either, but we will prevail. Okay, for starters, this is a cubic, so of course it's going to have a shape generally like a lightning bolt going up, but I'd like to know where its intercepts are if I can find them, and that means trying to factor this thing. Um, I don't see any obvious way to do factoring by grouping and get a quick win here. So I think what I will do is graph this. We'll use a little bit of technological cheating just to save us some time. So this function is y equals x cubed minus 3x squared plus x plus 4. And if we graph that, oh, is there really only one? It looks like it may have an x-intercept right here at -1. Let's see if that's true. Calc 0. And I'm going to have it look just in the neighborhood right around that intercept. Left boundary, right boundary. Oh, shoot, it's not even at -1. It's just an ugly number. Okay, minus 0.893. That's. I was hoping for better news than that, but okay. So our cubic comes up, inflects, and rises like so. That is x cubed minus 3x squared plus x plus 4. And this intercept is not a nice number, so hopefully it isn't too important. The y-intercept is positive 4. I don't know how important that's going to be either, but it's something we can get without too much effort. And the other side of this is the parabola minus x squared plus 4x plus 4. That also has a y-intercept of 4, which is a little bothersome. It means it passes right through this point. And if it opens down, let's see where its vertex is. Negative x squared. Now, if you're veterans of the graphing unit of this course, then you could graph this and find its vertex and all kinds of other interesting facts about it without ever picking up a calculator. But in the interest of keeping this from being a half-hour demonstration, we will let the machine help a little. All right, so our quadratic comes up, passes right through 0, 4. It's higher than the cubic all through here, and then they intersect again at that point. I'll bet this section is the area that we're going to be sent after. So we'll go red for the quadratic. It comes in a little flatter. It passes right through 4. It's higher all through this. It turns back. Okay, so they want the area bounded by those two curves and the y-axis right there in quadrant 1. Okay, yeah, I don't believe there's any other finite areas that we could go after, but fine. So in quadrant 1, we have all this, starting at 4, where it's very skinny, all this area, all this, all this, all this, all this, over to whatever this point is. And I feel like we're going to need that point, aren't we? Here we know x equals 0, so that'll be the left end of our integral. Here we must find out what's going on. Where is that point? Well, it's the point where x cubed minus 3x squared plus x plus 4 is equal to minus x squared plus 4x plus 4. It's where blue curve equals red curve. So can we solve this? It's a cubic, which means it can get a little challenging, but let's at least get it equal to 0, because that's a good place to start with polynomial equations. If we take this minus x squared over here, it becomes positive. So the x cubed just sits. Add an x squared to each side, and we end up with minus 2x squared. Subtract 4x from each side, and we get minus 3x. Subtract 4 from each side, that just drops out, and okay. Well, that's a little better because it's not a full-on cubic anymore, because it doesn't have that last term. It doesn't have 4 terms for us to deal with. This has a common factor of x, which is pretty great. We can take that out, and hey, it's not a cubic anymore, it's a quadratic. I'm feeling a little better about this now. Is this factorable? Our x just sits there. If we can find two numbers that add up to minus 2 and multiply to minus 3, and I think I just did, then maybe we can get this. I'm just going to FOIL this and make sure I got it right. X times x is x squared, plus x minus 3x, yep, and minus 3 times 1 is negative 3. So yep, this is a correct factorization. And so this says that these curves cross at 0, which we knew, at 3, and at negative 1, which I did not see coming. Apparently there's another intersection out here. Okay, well, the two that interest us are when x is 0 and x is 3. 0, 4. And this is 3, something that I don't really care about. It's the fact that there's an intersection there is what matters. That tells me that when I integrate, I'm going to integrate from 0 up to 3. So if you wanted this point, by the way, you could take 3 and plug it into either one of these functions, because at this point they should agree, right? They're both equally high. So you could take 3 and plug it into this function or this function, and whatever y value you get, that would be your point of intersection. So if we're finding an area there, we're constructing all these area rectangles, their tops would be minus x squared plus 4x plus 4. Their bottoms would be the cubic, x cubed minus 3x squared plus x plus 4 dx. And we're integrating from 0 up to 3. I'm just going to, I can feel that this is going to take a lot of space, so let's start conserving right away. All right, well, there's lots of like terms in this that we can collect, and I think that's a good idea before we even start the integration. Keep things as tidy as we can. For the x cubed, we have minus x cubed. I'm doing descending order. For x squared, we have negative x squared plus 3x squared. For x's, we have a 4x here minus an x. And then we have 4 take away 4, that's just gone. And it's not an integral until you have a dx on the end. Okay, so can we get an antiderivative for this? Probably. Minus 1/4 x to the 4. Plus, this comes up to x to the 3, and then we divide by 3. This comes up to x to the 2, and then we divide by 2. And no need for the c because it's a definite integral, and we're evaluating that from 0 to 3. All right. So when we plug in 3, 3 to the 4th is 81. Minus 1/4 means we get minus 81 over 4. 3 to the 3rd is 27. 2/3 of that is 18. 3 squared is 9. 3/2 of that is 27 over 2. Minus. And a wonderful thing happens when we sub 0 into this. All these terms vanish because they all contain x. So Minus 0 plus 0 plus 0. That's all we get from that second piece. Now, common denominator, because we got a bunch of fractions here, so minus 81 over 4 plus 18 is 72 over 4, plus 27 over 2 is 54 over 4. Minus 81 plus 72 is negative 9. Negative 9 plus 54 is 45 over 4. Yay, we win.